Okay, so I'm going to apologize in advance. I'm very good at running over my time when I do a presentation, so this may eat into the break a little bit, hopefully not too much. But when we're reaching the end, if you guys prefer to do questions, I can skip the last couple of slides and replace them with your questions. So very quickly, who I am. Currently, I'm working as an OpenStack engineer for Rackspace. I wrote the O'Reilly Flask book and wrote a bunch of extensions for Flask. What I like is Flask, if you don't know that yet. And then there's a link to my blog. If you want a reason to hate me, you can go read the latest article, the most current one. That's on how to use a Windows machine for developing open source. That generated a lot of hate, unfortunately. Some people hate Windows with a passion. So anyway, so this is about APIs. So I'm going to start very simple. Many people ask me, what's an API? They don't see the difference between a web application and a web API. So all an API is basically the set of rules and protocols by which two components talk between each other. That's all there is to it. So for example, let's say you're writing a Python script that needs to take command line arguments. So you go use rparse or click or one of the 1,000 other command line parsers. So you're going to have to use an API to talk to that library. Typically, these two components that have the API talk, one needs something done, and the other does that something, right? So you have a client and a service provider. And basically, in most cases, the service provider exposes the API, and the client follows it. But in the case of, say, command line parsing, there's a client, but there's no server, right? And we usually hear people talking about client-server APIs. So in that case, in the command line parsing case, you have a client, and the service provider is not a server. It's a service that runs in the same process as the client. So there's no server in that case. So here, at least for this talk, we're interested in client-server APIs. Those are the APIs that we see in web development. So let me show you one way in which you can have client-server APIs. So this is called the FAT server. And here you have a client that presents the application to the user and accepts the user's input. And then the server does everything else. So the server has the entire application logic. It renders the application, which for a case of a web application will be rendering the HTML, CSS, all that stuff. Even though the client accepts the user input, it is the server who acts based on that input. So the server handles that input. And finally, the server also has the database data, whatever data you need for the application. This is called FAT server because most of the things are done in the server. You probably realize this. This is the traditional web application style, right? Web 1.0, I guess. Basically, you can do this with Flask, Django. They're all very friendly to this. Now, can you see the API here? What's the API between the client and server? It's very simple. It's a subset of the HTTP protocol. The client runs a web browser, which is a really dumb application, sorry, but it is. So the client sends a GET request to the server, and the server responds with a web page, right, which is a collection of files, HTML, CSS. And then the client shows that to the user, waits for the user to do something, which could be clicking on a link or filling a form and clicking the submit button. And then the server sends a post request or a GET request, depending on what the user did, and the cycle repeats. And that's constantly going on. So that's the API in this case. Now, the other major model in web development, it's the FAT client. So if you remember the previous slide, the three items, application logic, rendering, and user input handling, were server responsibilities in the previous one, and they were moved to the client on this one. So here you can see that the client does most of the work, and the only thing that is on the server is the data management, so handling database or whatever else data needs of the application are. But the client runs most of the application. So you can probably recognize this too. This is the Angular.js type application where most of the application downloads to the client in the first connection, and then the application runs in a single page and only contacts the server to get data services. So typically, the applications that you see in the real world are in between these two extremes. There's usually a combination of the two models. But what we're talking about here is the REST APIs, which is a very good model for this type of application style. So we're speaking about REST. So next question is, what is REST? And this is my definition, kind of. Some people may not agree with this, but it's basically an architecture style. It's meant to be used by highly scalable applications, networked applications, so client-server. And typically, these applications run on top of the HTTP protocol. If you read the REST paper, you're not going to see much of a reference to HTTP. Supposedly, you should be able to run REST on top of other protocols. But as far as I know, nobody does it. Everyone does it over HTTP. So important thing here, highly scalable. A lot of people don't get this. People debate if this application is RESTful or not RESTful, and the problem is that people don't get that REST was designed to be highly scalable, which is something that very few applications need. I mean, if you're a Twitter or a Facebook, you do need this. If you're writing a little application to open your garage door, you don't. So REST may not be a great model, even though you could use it, and I do use it. But people are going to criticize you if you don't make it, if you don't follow the entire list of constraints for REST, which in that case you may not need. So REST has 6 principles. It's a list of 6, a short list, even though one of them, the one that's called uniform interface, is really loaded. It seems simple, but it's super complicated. And even on the original REST paper, it's divided into 4 things. So these are the 6. I'm not going to spend a lot of time on these here. I'm going to talk a little bit about uniform interface. But if you want to learn all of these, the talk that I did at PyCon early this year is about that. So you can learn about these 6. You can look it up on YouTube. Is your REST API RESTful? That's the name. So this uniform interface requirement for REST API is based on the concept of resources. So the idea is that the resources represent the entities of your applications. So for example, traditional applications, you will have customers, invoices, products, players, games, whatever it is. Those are your resources. Maybe not so traditional, but now with the Internet of Things movement, I think this is becoming more mainstream. You may need to write an API to control a physical object. I personally do a lot of tinkering with cameras. So that's, again, a camera could be a resource. A garage door could be a resource for your API and sensors. You represent each resource with a unique URL. You also represent collections of URLs collection of resources with a URL. So for example, you have a collection of customers, that's going to be a URL. Each individual customer is going to be a different URL, so they're all unique, and they can be uniquely identified. Here's an example. This is a URL for the collection of customers. It's pretty explicit. This one is for a specific customer. This is a customer with ID 123. And here's one that's even more interesting. This is a sub-collection. This is the collection of invoices for customer 123. So these are all valid ways in which you can organize the resources in your API. When the server talks to the client and the client talks to the server, they need to pass information about these resources. And the way that works is they use resource representations. And the representations don't need to match the actual resource to the dot. So if I have a camera, for example, there's really no way I can send a camera to the client, right? I need to find a way to represent that camera with data. So your API will have to find a way to represent the entities of your application with a representation. You need to choose a format that you want to use. And typically these days, most people use JSON. So that will be an example of a person. It could be a customer or a person. Same thing with XML. Most people hate XML. Me too. But it's the same data. You can make your API work with either one. And I'm going to show you some ideas on how you can basically not care about the representation that you use. It's really someone else's problem. So the dynamics of the interaction between a client and a server, it works like this. The client sends a request to the server, and the client needs to, one of the things it needs to tell the server is what action it wants the server to perform. And for that, it uses the HTTP method in the request. And there are pre-established, most people use these GET request and POST and delete and put with explicit meanings. Usually you use the GET request to read a resource, POST to create a new resource, put to modify a resource, and delete to delete a resource. So you use those methods to tell what you want to do. A lot of people get confused and put the action of the request in the URL. So for example, if I wanted to open a garage door, it's very tempting. And I see this all the time. People do, I don't know, API example.com/garage door/open. So basically you're putting the action in the URL, and that's not really very scalable. Usually you find a way to specify the action between these, within these four methods. And there are more. Most people use these four, but there's a few others that you can use too. Then you need to say in which resource you want the action to be carried on. So you use the URL field of the request for that. And all the resources have a unique URL, so this uniquely identifies the resource. And then for some requests, the client needs to pass data. And for that, you use the body of the request. And you pass the resource representation. If you need to do caching or metadata or anything else, that goes in the headers of the request. So the client sends a request, the server receives it, carries it, and then it sends a response. And the response also has predetermined fields for all the things that the server can indicate back to the client. So status code in the HTTP response basically tells the client what's the result of the operation. And there's a long list of status codes that can be used. Here are just a few. 200 is the OK. 201 is created. That's when you create a new resource. That means that the resource was created successfully. 202 is when the request cannot be completed immediately. So the server accepts it and then carries it in the background as an asynchronous job. 404, you all know 404. That means a resource that doesn't exist, and so on. There's a lot of them. Again, like in the case of a request, the response body will have the resource representation. If the server needs to provide, in the case of a GET request, for example, when the client wants to get a resource, the body will have that source representation. And once again, metadata for things such as caching, content types, all those things go in the headers. So, okay. So this is a $1 million question, right? Why I want what I like Flask and not something else. So pretty sure if you don't hate me for that blog article that I mentioned before about Windows, you're going to hate me about the next slide. There we go. So this is pretty clear, right? Left side cool, right side not cool. Okay, well, hold on. Wait. So I presume some of you don't have kids, so you don't have an excuse to buy these things, but I do. So I'm going to tell you what's inside these boxes. So when you go buy the one on the left, you get a bag or multiple bags of little bricks. It's completely unassembled, so it doesn't look like that picture, right? That's the end goal. And you get a very thick instruction manual, right? And that manual is like an IKEA thing. It's all pictures, no words. And it shows 3D renderings in 2D of how you need to assemble all those 1,300 bricks, right? So if you have enough patience to go through the entire thing, eventually you end up having a Millennium Falcon, right? So most of the time you're building this, you're looking at what you're building, and you don't really see the Millennium Falcon. You see a thing, eventually all the pieces come together and you end up having it. But you don't understand what you're doing. You're just following instructions that are not yours. So anyway, that's on the left. On the right, you just get a tub of bricks. So you get a uniform assortment of bricks of all colors and shapes, and no instruction manual. Or if you get a manual, it's a simple manual that you never read, because you just go and build your thing. So if you give this to we're doing an analogy here. I hope you realize that. So to a Lego builder beginner, say a toddler, right, 3-4-year-old. If you give her the box on the left, she's going to play with it 5 minutes, if she lasts 5 minutes, and she's going to give up, right? There's no way it'll do anything useful with it. If you give it the one on the right, though, even though she may not have seen Legos before, she'll figure it out, and she'll start building things, simple things, right? So same analogy with web development that I see. Another thing, if you try to build something that is not a Millennium Falcon with the box on the left, you're going to have a lot of trouble, right? For certain, you're not going to be able to build anything that is not gray, right? Right? So there's no option there. Another thing, you're going to find that the most common brick shapes are not, there are not that many of those common shapes that you use to build a lot of things. So if you want to build a house or a dog or a wall, you're going to run out of those, common builds, common bricks very soon. And you're going to find a lot of pieces that have really weird shapes. They look like they come from a Millennium Falcon, right? So if your job, is to build Millennium Falcons, it's a great kit to have, right? But if you want to build your thing, I take the tub, right? I will not think it twice, and I want to build my thing. So I see Flask and its wide collection of extensions as a tub of Lego bricks, and you build what you want with it. So that was kind of a joke, whatever. But now, speaking seriously, or a little bit more seriously, if you read the Flask website, there's a list of features. I copy-pasted that list here. It's this short. So this is what's in the box section of the Flask documentation. So take a look at this one specifically for APIs. So one of the main features of Flask is RESTful request dispatching. So I'm going to tell you what that means. So here's a function. I'm not showing you the function the implementation, and I'm not showing you the name of the function. I put a generic name. So here, even though there's nothing, I'm not showing you anything. I can tell you right away what this function does. App.route is the way you associate URLs with functions in Flask. So I can tell you that this is a request for the customers list, and this is the GET request, which means that this function returns the list of customers. So very simple. Here's another one. Same thing, but post. This creates a customer. One more. Customers/ID. And the method is delete. So this deletes a customer. So when I think of Flask as a REST API framework, and a lot of people is concerned that when they ask me what's my RESTful framework, I say I use Flask. I don't need any extension or plugin or anything. This is why. It's very simple to write your API endpoints, and I don't need anything else. So creating APIs with Flask. I'm going to try to go very fast through this. But first, so this is a quote from the 80s. I'm not sure if you heard it. The oldest of you may have. 90% of the time, 90% of the code accounts for 90% of the time. The remaining 10% accounts for the other 90%. There's no typo there. This is a universal truth about software development. Okay, it was said by Tom Cargill back in the mid-'80s, I think. It's a very old quote. So I'm going to just run through this. Basically, these are the main things that everybody gets. This is very easy to do. 90% of the time you spend doing this. You do your endpoints. You need some code to handle your resources, which could be a database, or if it's a camera, for example, a package that manages the camera. You need some way to create representations, and you do that with either JSON or one of those standard library packages, or you can use Flask RESTful, Marshmallow, any of those. Really, with Flask, the choice is yours. It's a tub of Legos, so you pick the brick that you like. You can do authentication, or you should do authentication. I wrote an extension that helps a little bit with that. It's called Flask HTTP Auth. You need to make sure that you return your status codes correctly so that the client knows what's going on. And you can use Python modules to do encapsulation for your resources. You can see examples of these on the code that I presented at PyCon this year, if you want to see an example of a running application. But the problem is that there's the other 90%, right? And this is, I mean, you feel pretty good that you wrote an awesome API, and now you say, okay, I'm just going to wrap it up. And this comes up. Right? There's a lot of things that you don't really care about that, I mean, for an API to be friendly to the client, you need to implement. So you can choose not to, and it's fine. A lot of people don't. OpenStack don't do a lot of these things, OpenStack being, the big thing it is. So, you can choose not to. I like to write code. I enjoy the act of writing code and writing beautiful code, maintainable code. So I do all of these, and you can see how I implement these on my GitHub, on the code that I presented at PyCon if you want. But basically, I do it using decorators. And that's the way I get all these things that I don't care about out of my code. I want my code to be the main thing that you think about when you're writing it. I don't want to see code that does caching in the middle of code that does the application logic. So I just shove it away, implement these decorators. So this is not Flask. All these decorators, collection, JSON, eTag, all those I wrote, but I managed to keep them away. I don't need to see them because they're not important to me. I just need to have them for the client to have a useful API, a friendly API. Here's another one where I get an asynchronous thing just by adding a async decorator. So I write the function as if it was synchronous, but then I make it asynchronous by adding a decorator. Done. Okay. So do we have time for questions, or did I run over all my time? Oh, awesome. Okay, questions? Here we go. Yes.
Very basic. So is Flask a module like
Oh, very good question. Yeah, I thought most people will at least know the hello world example in Python. So yes, I'm sorry I didn't mention this. So Flask, you say import Flask, and you basically get the main thing is it's a Flask class that represents your web application. And from there, you draw a lot of functions. Actually, Flask also offers an API to to the developer. You get to use you have to use the all the services that Flask provides, and it's very simple to use. If you go to the Flask documentation on the main page, you see a hello world application that's very simple. It's actually let's see, very similar to come on. To these examples where basically you have a function that does something and you attach it to a URL by adding the app.route decorator just right above it.
So do you still need the request module or URL?
So requests is a library to make HTTP requests. This guy receives the requests. So you do not use, you could say that this is actually the reverse of requests. So this is the receiving side of requests. You could use requests to make calls into this. Yes. How does that work? Okay. So I have a couple versions of that guy. So for this one, async basically, so I should probably give a little bit of introduction on how the decorator works. But when you put a decorator on a function, the decorator gets to run first, and it receives the function as an argument. So it can do things before calling the original function or after. So in this case, you could make the decorator start a thread and then call this function from the thread, and it really makes no difference. So that would be one way in which you could implement this, and I've done it. You need to look at the. I did a video class on for O'Reilly on APIs, and I implemented a camera. Actually, this example pretty much using starting a thread and then running the function in the context of the thread. So basically, you start the thread and then you send the response, which will have a 202 response that tells the client that the request is ongoing, and then the client gets. If you see here, I'm returning a URL on this function. So the client with a 202 response gets the URL. So then the client sends a GET request to that URL to get status. That way it finds out when the request finished. And then it can get, in this case, a movie or whatever else it is. So this is kind of an advanced thing. As I said, I really like hard problems, so I think about them a lot, and then I look how to implement them in ways that are clean, like this. So I'm kind of crazy about that a little bit. Yes. So well, I guess the question is if by having too much freedom, basically that's what you're asking. If you have too much freedom, aren't you risking getting away from what the REST protocol dictates? Well, I'm going to tell you the truth. Most REST frameworks, so-called REST frameworks, don't follow the REST to the dot. I'd say pretty much all of them have things that they don't implement. So you have a better chance of being RESTful if you are careful and implement REST your way, versus relying on a framework where if there's something the framework doesn't do, say it doesn't implement filtering for your collections, it's going to be very hard to get that framework to do something that it doesn't do originally. Versus here, where you can implement it your own way, you can implement, in the case of filtering, your own filtering language, filtering criteria. So I see it, I mean, if you want to write good software, I see this as the best choice. You can probably build an API, or I'm sure you can build an API with any framework, but this will give you the control and way to make it better, I think. Anything else? Yes. It's a Millennium Falcon. So it's all about choice, right? I'm not saying that that's Django and I hate Django. I didn't say that, not at all, right? I did not, right? You said it. It depends on how so let's put this example. So maybe you don't care about, it's your job, you need to get an API done the quickest way possible, you don't care about doing it maintainable. I mean, there's nothing wrong with it. I want to have, I'm a control freak. I want to make sure that if someone complains about something that my API doesn't do, I want to be completely sure that I can expand it in the future. So for me, the type of Flask extensions is the best way to go. But there are APIs that work and work well that are written in Django or anything else, right? OpenStack it doesn't use Django or Flask. At least most parts of it don't. And there are APIs that people use. They work. Yeah, people complain about them, but they work. So who am I to say what to use, right? I just use what makes me happy, and to me, having the control is what matters. Oh, one more, yes. If it's used in production or? Ooh, you asked the question. That's Flask scale. So people seem to be concerned with that a lot for some reason. So the question that I ask in return is, can you scale, right? Because you're going to be writing your application. You need to make sure your application scales. Flask is a tiny library. It helps you with not having to deal with the HTTP protocol, yourself. Basically, it helps you a little bit with that. It makes it a lot easier. But really, you're going to be writing your application. Your application needs to scale. And that's true for any framework. You have to make sure, if you think about a real-world application, the portion, let's say you measure the time spent, you like profile a request, right? An HTTP request. The portion of the time that request is going to be in Flask code or Django code or whatever else code is going to be a tiny portion, say 1%. The rest is going to be your application running, right? If you're doing something meaningful. So it's your problem. You have to make your application scale. Yes. Oh, I'm in trouble. Oh, okay. I think Discuss also uses it or used it at some point. Discuss the comments thing. Or Twilio, of course. They wrote Flask RESTful. It's one of the things that I recommended for marshalling representations. Yeah. So I don't know. I mean, software is hard. I mean, if anybody tells you that writing code is easy, they're lying. It's hard and it's fulfilling hard. So, You have to learn it. And once you learn it, you can use anything. And I'd rather have control versus have a framework that controls what I do. Okay, thank you.